Hey guys, welcome back to the basket case Predicta Siesta restoration project. I'm going to call this phase 2. Phase 1 being doing a resurrection. By that I mean doing as much as I could to get the set running without taking the main board out and shotgunning everything. So we got a halfway decent image and some weak sound. We know all the major components are good. Had to do a few hacks though along the way. The vertical linearity control is shot. I had to tack in a resistor here to bypass it. In fact, we got quite a few parts just tacked in and hanging in free space. Obviously not safe and not a reliable way to do it. Also had to hot wire one of the filament pins on the damper tube because there's some issue underneath the board. So the time has come to pull the board out. So that's what I'm going to be doing next, and along the way I'm going to be cleaning things because of the remarkable transformation on the tuner simply by spraying it with some simple green and some hot water. So I think next up I'll do the high voltage box just because that's easy. So I'll spray that and let it sit for a while I start working on this. So I disconnect everything. Also need to rewire some of the CRT wires that are all crusty and cracked. So to get the board out, I need to go around and undo a number of wires that are twisted onto these little stakes, and then unsolder some stakes that are in various parts around the board that provide not only a means of anchoring the board but also ground connectivity. And then I can pull the board out, and then we can really go to town on it. And if you missed it in the earlier segments, I will be using these replica networks or cup plates made by the TV restorer guy. I've already tacked one of them in place from above. I'll be replacing the rest of them once I get this board out. Now, if you haven't done this before, it can seem pretty intimidating. I've done this, well, a bunch of times now, so I'm not too daunted by it. Plus, I have a few other chassis around, so I don't have to worry about labeling the wires so I know how to reconnect them. I also have original Philco service info that pretty clearly labels all of these and shows you where they connect up. I'm just going to start digging in. I'm just going to start pulling wires. I think the board is ready to finally come out. And I discovered one thing along the way. I don't think there was ever anything wrong with the damper socket. Remember, I had to jump one of the filament pins to get it to light up without me having to put pressure on that area. That wire I had to jump was ground. Well, what's right next to this tube, one of the grounding stakes that goes to the chassis, it was broken off. I think somebody had been in this set. Well, I mean, I know somebody had because there was some work done. But the wires were all still factory wired to the stakes on this. There's no way somebody took those off and put them back on. But every one of the bent over soldered on connections onto the board had been monkeyed with, it looked like. Because I found two of them that were broken. And I wonder what else was going to that ground that might have been an issue. So with all my trying to monkey with this socket to make it work better, I think I might have actually kind of screwed the socket up now, so I may end up having to replace it, but not because it was bad in the first place, but because by me putting pressure on it and trying to shim it up, I think I might have damaged it. Alright, now getting this out is a little tricky because one edge of the board is underneath the vertical output transformer and another is underneath this range switch. And there's a little bit under some wiring on the other side. I can't remember how I've done this in the past. You know, I'm going to unmount this vertical output transformer. There's just one screw holding it down. That aside, slide the board up, over, maybe, come on. On something over here. Not sure what. This whole side's completely loose. Something in this corner it's stuck on. Maybe I gotta heat this connection up a little more. There's a whole bunch of wires that go over in this area. There we go. They were all really bunched up. Just going to move these wires aside. I think we're good. I find these harder to work on than the 21-inch sets. There's a little bit more breathing room, I think. Oh, there's one wire I didn't get yet. There's a few ways to get these off. Use needle nose pliers. You can just cut them. They usually break off because they're kind of brittle while you're unwrapping them anyways. Yep, one more wire over here too. Finally. All these wires, when you unwrap them and try to get the board out, they kept getting hooked on everything. There it is. Now, voila. So there's that damper tube socket. And yeah, I don't see any problem down below. No cold solder joints, nothing. So there's a grounding stake that wasn't making good contact, and that goes right over to that pin, and that's the one that I had to bypass. And it also goes over to this pin on this guy, which is the horizontal oscillator tube. So if that wasn't being grounded, I imagine that was causing some problems too. So, what next? I think I'm going to give this a bath with that simple green. Very carefully. There are some coils on here, like this guy. They're kind of a Oh, it's a construction style that seemed to come into being in the late 50s. Certainly not unique to Philco, where the coils are vertically mounted inside of these little plastic holders. And of course, there's these coils. But after seeing that tuner, which is more delicate than this, I would say that the tuner came out quite well. I'm not too worried. I'll take the tubes out before I plunge it in the sink, in the utility sink. Here it is, straight out of the oven. I only did about 8 minutes. Again at 175, and it's in a convection oven. That's the type of oven that has a fan that circulates the hot air around. And none of the plastic got deformed or anything like that, and it seems to be thoroughly dried out. So I'm going to get to it. So one by one, I'm going to take the parts that I mounted on top and remove them, remove the stumps of the old component leads and mount them flush down to the board, and remove the remaining couplates and put the new ones in there. And here's that damper tube socket. I'd like to replace it. I'll try to dig one up that's compatible with this circuit board layout. And I might replace some of these as well. So the tube sockets that Philco chose to use in these Predictas, especially the 9-pin, the metal is not perhaps as thick as it should be. So with repeated removal and insertion of tubes, it can form stress cracks in these. Surplus Sales of Nebraska has drop-in replacements that look identical, but the metal's about twice as thick. I do have some of those on hand. They also have the 7-pin with the integral shield like this, as it does one other supplier. I'll put a link in the description. But examining these sockets, they actually all look to be in fine condition, surprisingly. Now that this circuit board is out of the chassis, it's a breeze to work on. I've done some in-depth videos in the past showing the technique I used, but I thought I'd do a quick recap here. So all these components are mounted on the top side, the leads go through to the bottom, they bent them over, clipped them, and then soldered them in place. So one way to get a part out would be to desolder it from the bottom, carefully pry up and straighten out the lead, and then pull it out from the top. However, when you do that, you stand a good chance of stressing the copper foil on the bottom and lifting it up. This board is made out of phenolic insulating substrate, and then they use heat and pressure to bond the copper to it. You apply heat to this copper, it tends to separate from the substrate and start peeling up. So we want to minimize that. So I do it from the top. I don't care about salvaging these parts. I'm never going to use them again. So what I do is I clip it out up above. So let's see, we want to replace this 100K 1-watt resistor. I clip it out from the top, leaving a little bit of the lead left that's completely vertical. And then I heat it from the bottom, and it'll slide straight down because there's no, it's just a straight little bit of lead that's left sticking up. So it's out, and I'll flip it over, and here's one of them. I'll heat it up. I'm actually pushing it with just my finger, and then usually I can hook it with a soldering iron tip, and there we go. It's out, and the hole is clean, and I can just stick the new component lead right through it. Got one left to do here. Yes, if you don't want to risk burning your fingers, you could use a tool of some sort. And quite often, it just the little bit of stubby lead just sticks to the soldering iron tip. flick it off, and that's that. And here's the replacement. Yes, it's smaller, but this is a 1 watt, or sorry, this is a 2 watt resistor. These are made by Vichy. I like to use them because they're not bright blue or gray. They kind of look like the nice old carbon comp, and the colors are easy to distinguish. That's why I especially like them. They're also metal film, which is very temperature stable, and they're inexpensive. And they have nice thick leads. They didn't skimp on the wire gauge. So I'm going to preform the leads. Now, because this is a higher wattage resistor, I like to mount them off the board a bit. This is going to get a little warm. You can see the board's a little bit discolored where it used to be. And because this is smaller, has less surface area, it's going to get the heat will be a little bit focused. Bent the lead a little bit too close to the body, so I'm going to straighten it out, rebend it. That should do. Here. I tend to do these one at a time because I don't want to lose track of what I've done, but often I will clip out and remount a bunch before I bother soldering and clipping all the leads. So I'm just holding the body up off the board a little bit while I bend the lead over on the other side. I got maybe a 1/16 or an 1/8 of an inch off the board. So now when I flip it down, it's hanging in space. Gravity's pulling it down, so it's away from the board. You could also preform the leads and put a little bit of a kink in them. That's how they typically would do it in a factory, to provide a little built-in standoff. But that takes a bit more time. And then we simply solder, and then I will clip the lead flush when I'm done. Zero odor now that I cleaned all the nicotine and tar and whatnot off of this. And that's it. Nice, neat, new, shiny resistor. And I'm doing the same thing for the caps. So here's that cup plate that I had just tacked in from above before. Now it's seated down further. Here's some other resistors I've done. Here's a capacitor I've done. So some of these caps were originally horizontally mounted, and say something like this. So when you use these new little chiclet style caps, you have to stretch the leads out and bend them down. But quite a few of these caps are vertically mounted, so for the replacements, using these little guys actually works out quite well. Now, one of these caps in particular, I think I've already discarded it. It wasn't this one, but it looked just like it. It was a .0039. It's the one that I just showed you that got replaced. Remember, the horizontal frequency was so far off on this that I had to back out the core that much. And yes, it's chipped, but I don't think it would have that profound an effect on the free-running frequency. But what's in parallel with that coil is this capacitor. And the one that I had removed was cracked and was leaky. So I think that's what was really throwing off the free-running horizontal frequency on this. So I don't doubt when I go back to power this up, when I put the board back in, I'm going to have to adjust that frequency again. One last thing I want to talk about is the tube sockets. So here's that damper tube socket that I was struggling with so much. It turns out that the socket is just fine. It was the connection to the chassis that provides ground to one side of the filament that was open. However, partly it's a little messed up now for me trying to force and pry and bend the tube contacts. But also I've had some issues with both of these octal sockets in the past, so I'd like to replace them. However, I don't have any drop-in replacements for them right now. The others, though, I do. So the 9-pin you can get from Surplus Sales of Nebraska. They have Last time I looked, they said they had 29,000 of them in stock, so they're not going to run anytime soon. They are identical in every regard other than the plastic looking a little mottled. They probably used some surplus plastic or some such. I don't know why there's orange streaks in it. But the other difference is the metal is a thicker gauge. So here's one of the original sockets, and here's the replacement. I think you can see, I hope, that the metal is a little thicker. But otherwise, the pins line up exactly, and it's the same type where the pins kind of snap in and they're split, and that kind of forms a solder cup when you solder them in. Getting these out can be a little tricky. I'll demonstrate it. One I want to replace for sure, although all of these seem to be fine. Since I've gone this far, I'm kind of inclined to replace them. This was a vertical output tube, and for me, inserting and reinserting and screwing around with it so much, I think I stressed it a bit. However, to get them out, again, just like with the other components, having to unsolder all these from the bottom and then carefully pull them out is a pain. Also be aware that on some of these tube sockets, as well as the cup plates, they crimp some of these leads. For example, this center pin, after they put it in, probably to hold it in place while they're soldering it, they squeeze it and crimp it. You need to cut this off or uncrimp it or do something to get it to go back through that hole without damaging and stressing the board out. So what I typically do on these is I use a tool like these nippers, and I destroy the plastic from the top. I just get in there and start cracking it apart. It's pretty brittle plastic. Not hard to do at all. So I'm obviously committed to replacing this socket. And I break it down until there's just a little bit of metal stump remaining, and then I try to heat it up from the bottom and pull it out. The 7 pins, some of them are available from surplus sales in Nebraska. I think they only have the style that have the integral tube shield like this guy, which I also definitely want to replace. This is a 6 CSC audio tube. I use that for the detector, I believe. I had some trouble with getting the filament to light up on that tube. So again, drop-in replacement, a little bit superior shield. This one is kind of made from some sheet metal that's just overlapped, whereas this is a nice continuous band. And finally, here is an unshielded 7-pin version. I think I got these perhaps also some surplus sales in Nebraska, I'm not sure. And this is identical to the type they use in the Holiday, the 21-inch sets. Let's see, are there any? Okay, I guess there aren't any unshielded 7-pin sockets on this. So, but if you're doing a 21-inch set, this is the type of replacement you want. I also saw these 7-pin ones available from another vendor. I will try to remember and dig that link up and include it in the description. The only downside to getting these is they do have a minimum order, so I sometimes struggle a little bit to fill up my order. So I ordered a bunch of these sockets, and since I've got so many Predictas now, I didn't realize I was going to be picking up some money the last time I placed an order, so I probably should get some more. Now, the one thing I haven't found yet is a drop-in replacement for these octals. I will take another look at surplus sales and some other vendors and see if somebody's got something that looks right. These are a little bit different down below. It looks like it's sort of a flat metal tab that kind of goes through the hole and then bends over a little bit, rather than having these kind of cylindrical pins on it. Alright, so that's that. I'm just going to go through, I'm going to blow through and replace everything. Sorry. By everything, I mean every carbon composition resistor, every paper cap, and the tube sockets. I am not going to touch the coils or the ceramic caps, and probably not the mica caps. There's only 2 of them. They're in the horizontal circuit down in here. Some guys do. They say their failure point, the 390 picofarad in particular. I'm not really concerned about it, but Oh, and of course all the cup plates will go.